Good evening, everyone. Are my slides visible?
Good evening, sir. Yes.
Yeah, thank you. So, I'll formally introduce myself. I'm Manikandan. I'm a second year PMRF at IIT Bombay. So, this is week 7 tutorial based on the contents of week 7 of the course The Joy of Computing Using Python. So, as usual, we'll start up with some practice problems. So, here is the first problem in the quiz.
Sir,
Yes?
sir, I have not been able to attend any program solving sessions for the past few weeks due to various reasons.
Okay.
I was wondering when we could ask what problems we're facing during programming on our own.
Uh, okay, so if you so the problem solving sessions are recorded in YouTube, so you can have a look at that.
Okay, sir.
Yeah.
No, sir. What I was trying to say that I have been trying to solve week 8 assignments because they're due on Thursday, and I am facing some problems there. So I wanted to ask you about them. Besides doing the class, of course. So I
Okay.
was.
Okay.
So will I ask it after the class?
So maybe you can post your doubts in the discussion forum.
Oh, okay, sir.
Yeah. So we'll answer that over there.
Oh, okay, sir. Okay, sir.
Yeah. So because this is a very restricted schedule, if every student gets a doubt, it will be too hectic to solve at once. Yeah.
Yes, of course.
Yeah.
Okay, I understand, sir.
Yeah.
Thank you.
Okay. Thank you. Okay. So all of you, please try to answer this problem. So we are given a snippet of code. A list is initialized. A flag variable is initialized, and there it's a nested for loop. Okay. So if the flag variable is initialized to if it's 0, it does something. If it's 1, it does something else. So it's basically printing the elements that are present in this list. Okay. So based on the condition of the flag variable and everything, so what will be the way these numbers will be printed? So you have to guess that. Okay. So try it out and put your answers in the chat box. So I'll go through this question maybe. Yeah. Option 3D. Okay. Yeah. So the correct option is option D. One of you answered it right. So what this piece of code is doing, so we are initializing a list. So in this way you can count it as a matrix. Okay. So the matrix J is in the outer loop, so you can consider that as the column index. Okay. And the flag variable is in default initialized to 1. Okay. So when it takes 1 for any given column, we are printing out through all the elements in. Okay, so for any given column, so J is initialized to 0, the flag is 1. So when we enter this for loop, it will be 0 0 element will be printed. So 0 0 is 1. Okay, so you can easily eliminate this option A. So once that is done, so there is an so this end is to continue printing in the same line. Otherwise this \n new line character will be default followed in Python. So to avoid that, to write things in same print things in same line, we are using this end delimiter. Okay, now the flag variable is updated to 0, so that means we are exiting this for loop, because this if condition is no longer valid. Okay, so from here, after printing 1, we are going here. Okay, so now we are so there is another for loop. So this for loop is different from the earlier for loop in the sense the index is going backwards. So we are going from 2 to -1. So this -1 will not be considered because this is the end index. We always ignore the end one. So it will be 2 1 0. The I will run from 2 1 0. So these will be the values of I for each iteration. So I will take any value out of these. Yeah, so if you have any issues with the live session, you can always access the YouTube lectures. Okay. Anyways, so I will first take the value 2. Okay. So while keeping J as 0 and I is 2 now. Okay, so all it does is, so over here in this print statement, okay, I'll post my YouTube channel link. I've pasted the YouTube link to my channel, so you can access the lectures there. Any doubts? Okay, so all it is doing is, for a given column, this for loop will print the elements 1, 4, and 7. So these are the elements in the first column, first row, first element, second row, first column, third row, first column. Okay, so in the second for loop, all we are doing is printing the same thing but in the reverse order. So we are starting from 2, we'll print 7, and then we'll print 4, and then 1. Okay, so that's why it is going in this sequence 1 4 7 and then 7 4 1. And next we'll go to second column. So this, after all this, the control will go here. Now j will be updated. J will be updated to 1 from 0. We'll go to the second column and we'll print the second column elements top to bottom and then bottom to top. Similarly, third column top to bottom, bottom to top. Okay, so it's just a simple way. All the code does is it is printing the column values in a certain fashion, top to bottom and bottom to top for each column. Okay, so based on this, just by differentiating how this iterator runs, you can clearly look out this is the right answer. So here's the second question. So based on the turtle library that we had seen in the 7-week lectures, so a function is defined. A function called func is defined. So that is called in another function, func1. Okay. So we are given a square matrix mx. So dimensions of that is 70 by 70. So when you supply this matrix to func1 function, it is so it is calculating the dimensions of that, and then we are initializing a variable I to 0. So while I fits in this range, we are calling this other function func. So control goes here. Okay, and I is being incremented 10 for each iteration of this while loop. Okay, so in this function func, we are calling this turtle library. So assume that it is imported already. Okay, so we are initializing the position of the turtle, and there are some 4 loops which are through which we are giving some instructions to move this turtle around our frame. Okay. So based on these 4 for loops, it is just specification of position. So based on that, please try to answer which of the following options is true. So one of you have answered B. Okay, we'll get some more responses, then I'll discuss the solution. So I was just waiting for some responses from this. Okay, so I'll give you the solution. So the answer is B. So so without going through all these loops, you can go by the option of elimination. So to simplify, so the initial position is set to I comma I, and when the function is this func is called, I is initialized to 0 0, which means our turtle is initially positioned at 0 comma 0. So clearly this option does not satisfy that. So this is not 0 0. Okay. Just by hunch we can say that even this doesn't look like it's starting from 0 0. Okay, so out of these two options, B and C, we can check so we can apply some more logic and check switch between these two options. Okay, so so the initial position is 0 0. Okay. So for we have a running index I and D, which is in the range 0 to, in the first iteration it will be 0 to 70 minus 0. Okay, so n is length of this dimension of this matrix, so that is 70 by 70. So this will be 0 to 70. Okay, so till then it will go to that position. Okay. So for a given I, it is moving to I and D, where I and D runs through this, so it is moving in this fashion. Okay, rightwards. And then for I and D in the range, so now I is incremented to I plus 1. So now it will be 1 comma so this would be now 71 to 70. Okay, so all it is doing is it is completing this kind of a so all these 4 loops, if you plot the coordinates, all it is doing, it is completing a square, and then okay, so these 4 loops are doing it's drawing the sides of square, and then after that we are doing a jump of I plus 10. Okay, so now your I is incremented so much that now you will draw a bigger square every time. So this shift is what happening with this increment. Okay, so that increment is missing here. Okay, so we can cut off this option. So all we are doing is drawing a square and making it bigger and bigger every iteration with our turtle.
Sir, will you explain how it is not starting from 0 0 when the position seems to be at 0 0 only? First option.
Okay, so it is, so we cannot completely say it is 0 0. So I stand corrected. So it,
So where is the position 0 0? Where from it starts?
so from, so typically on a first look,
Which position is 0 0 position?
so 0 0 position is we can only figure out from the overall layout. So for a given point we cannot say this is 0 0 or not. Okay, based on the movement of a turtle we can say, like, we want it to start from 0 0, but yeah, so this can be 0 0 as well. but this is not having this jump, so we can eliminate this option. Okay, so please try this third question. So this is also using the turtle library. So a function func is defined, which is again taking a matrix of dimension 70 by 70. Okay. So func1 is called, okay, but okay, so line 2 seems to be, it is calling a function func1, but that doesn't seem to be defined in the rest of the code. Okay, then okay, maybe we can please ignore this question. It has some missing piece of code. So it is calling a function func1, but that is nowhere defined in the rest of the code. Yeah, that is not defined anywhere in this piece of code. So the fourth question you must be familiar. So in the Google Maps, which of the following libraries is used? So when given the latitude and longitude position, which library is used to find the shortest route between the two positions? Anyone? Okay, so that is ggplot. I think you all are familiar with that. So in this question, you are given 4 snippets of code. So which of the following codes represent the correct version of a board game where the user has to move from block 1 to block 100, okay, from step 1 to step 100. So the game initializes only when the user gets a 1 or a 6 on the dice, and ends once he reaches 100 or any number more than 100. Okay, for example, when he's at 99 and his dice rolls a 4, means the game's over, the player wins. Okay, so out of these 4 options, which piece of code does this, which one simulates this board game? Starts from 100, initializes only when 1 or 6 is rolled, okay, and the game ends when it reaches 100 or when the position is greater than 100 also. So is anyone able to figure out any guesses? Yeah, so the right option is option B. Snehal got it right. Yeah. So why this is the right option is because so among all the options, the initial position seems to be defined properly and calling of function is same. So the control starts from here. First your computer will see line number 18, position is initialized, it's printing the position, initial position, and then with the initial position we are starting to play. Okay, so 0 is captured here, the initial position, and then a random, so the dice is rolled now and a random number between 1 and 6 is picked, and based on that if the random number is 1 or 6, we are we are starting the game. Okay, we are updating the position variable PSN to 1. Okay, so when position is 0, when we roll 1 or 6, we are updating the position to 1. So that's all these lines of code do, 7 to 9. Else we continue rolling the dice. Any random variable that is coming out of the dice roll, we update the position with that, increment with that R. Okay, and then we print the position every time. So if the current position is greater than or equal to 0, we win and the control returns. And so that's how the game goes. So why other options are wrong is that, so here you can see it is incrementing by 2, so this is clearly not random. Okay, so it is not considering the randomness of rolling a dice, so this option can be eliminated easily. Option 4 is clearly wrong, and option 3 and 1 overall the logic seems to be fine, but some important messages are not clearly mentioned here. So in option 1, this print statement is not defined. So when the dice is rolled, but we don't know what is the outcome of the random variable, so this print statement should be clearly defined. So when we play a game, so assume a normal board game, so you always know what your outcome is, you see that. So we need to see that also. Okay, so visualizing that random variable, it becomes important. So that detail is missing in option 1, and option C is wrong just for a simple reason that this return statement is missing. Otherwise these first 3 options look very similar.
So in the first option, the else is in the wrong indentation. And in the third option, it's also taking input, but it's unclear what it's trying to do. The input part.
In third option, the input. Yeah, that is just an unnecessary detail. So that's also an extra line of code that is doing nothing essentially. And over here, this else is indented wrong. So this is also wrong. So the indent So this indent is meant to be this way, because if position is not 0, only else it does this random increment. Yeah, you're right. So a similar question based on this same logic. Imagine a single player snakes and ladder games. So the following code represents what? So we are so similar to the last question, we are initializing the initial position, and then we are calling a function play that takes the initial position as the input, and then the variables, the position of beginning of the snake and the end of the snake is initialized to some random integer -1. So while the snake begin position is less than the end position, we are choosing some, we are assigning some random variables to it. So we are printing the snake position, the end and the beginning. The range of the snake is from this place to this place. That is done. Then a random number r is taken based on the dice roll. After that, the position update is similar to what was done in the last case, except that over here in line 90, so here the difference in the code lies. Okay, so it's like when you're in a position where if it is equal to the snake beginning position, you are bitten by the snake, and then your position is dragged down to tail of the snake. Okay, that is end of the snake. So only these parts are different apart from the last question. Okay. And also the initializations of the snake end and beginning. Option B. So option B is not exactly right, because option B says that the position of the snake remains constant throughout the game. So that is not true, because the beginning of the snake and the end of the snake are randomly initialized every time we are playing the game. Okay, so option B is not right. Please look into the other three options. So option A also says the same thing, that the position of the snake remains constant, so we can eliminate that too. Any guesses? Anyway, so the difference between option 3 and 4 is that option 3 says that the snake can bite you any number of times, and option D says that the snake can bite you only once when you play. So among these two, what do you think would be the right logic here? So there's a typo, so this is once ONC. So the answer is option C. Okay. So that's because whenever we are playing, we can be at any random position on the board, and the position of the snake, the head and tail of the snake is also initialized very randomly. So it can be any number of times. We cannot put a certain number on it and label it. So we cannot say that certainly we'll get bitten by the snake only once. Okay, so because this position of snake is getting randomly updated for each turn we are taking. Okay, so it's not that. So if there was a break statement after this one, it might have been true. After this bitten by snake, it might have been true, but that is not there. So every time we play, the snake will be at a random position. So there is always a probability that we can get bitten by that. So this is question number 7. So over here, the same logic is being applied, snakes and ladders. So whatever was in the 90% of it is the same logic. We are initializing the position of snake. So before that, we are initializing our position as 0, and then we'll update our position to 1 when we get a 1 or 6, and the positions of snake is also randomly updated, just like in the last time. Okay, so once we start playing, our position is incremented by R. A random dice show up. Okay, so here is the difference in this question between lines 19 and 22. So we are having an if conditional. If our position is equal to snake beginning and flag is equal to 0, so we are taking one more input variable, so that's a difference. Flag variable we are taking as an input. Okay, so if that input is 0, default it is given 0. If that is 0, we are and the position is equal to snake begin, we are bitten by snake, and our position is updated to snake end. okay, and then flag is equal to 1. So the default value of flag is 0. Here the flag is getting updated to 1. So based on this, which of the following options do you think is right? Okay, so similar to last time, the position of the snake is randomly updated every time we play. So clearly we can eliminate option A and B. Okay, both say that the position of the snake remains constant. Okay, so A and B are not true. So the options are same as the last question. So option 3 says that snake can bite you any number of times. Option D says that snake can bite you only once. So this is again a typo. So it says the snake can bite you only once when you play. So over here option 4 is right, because our flag is getting updated to 1 after this we are bitten by the snake. Okay, so the flag variable should be always 0 for us to play. So that's how play is called. Okay, play the flag variable is 0. So once when the flag is not 0, we are exiting the control. Okay, so that's how the flag, because this is no more satisfied, right? This if conditional is no more satisfied and flag is 1. So we can never be bitten by a snake again. Okay, so for that reason option 3 is also wrong, which says we can be bitten any number of times. Okay, so question number 8. So assuming that a function play1 implements the recursive play of snakes and ladders with the pre-specified position of snake and the ladder as shown in the code below. So which of the following ambiguities in the option can result in the code? Okay, so we are calling a function play1, which is taking the input position, beginning of the snake, the end position of the snake, ladder beginning, ladder end. So the definition goes like this. So the positions end and beginning of the snake are randomly initialized. So that's what is happening here in this for loop, and similarly the ladder positions are updated here. So what could be the ambiguity over here according to the traditional rules of snakes and ladders? So without seeing the code also you can answer this one, just if you know the rules of traditional snakes and ladders.
So can you explain the question statement again?
So the question statement is that we are defining a function play1 that will implement the recursive play of snakes and ladders. So the positions of, so a recursive means it's in a the positions of snakes and ladders are updated randomly for each turn of the play. Okay. So what could be the ambiguity in the options which can result according to these rules specified in the code? So the code is doing nothing. So it is just taking some initial positions, player position, the snake beginning and ending, ladder beginning and ending. That's all. So if the position is like, if it's in the ladder beginning, we'll raise up. If it's in the snake beginning, we'll fall down. So those are the rules. Okay. So based on the initializations of the random updates of snake beginning and end positions and the ladder beginning and end positions, what ambiguity could be resulting? So there will be at one, yeah. So there will be one point you are at a position, say 90. So at 90 you don't know what to do, whether you should climb up the ladder or do something else, because there is some logic error based on these four positions: snake beginning, snake end, ladder beginning, ladder end. Okay, so option C. Yeah. So the correct answer is option C. So option C says that ladder beginning and snake beginning are at the same place. So when we are in such a position, we don't know whether to climb up or we'll fall down because of the snake. Okay, so that is so if that kind of thing is happening, like we should make sure that this coincidence never happens, that our ladder and snake are having the same, their beginnings are at the same position. Other combinations can be fine. Snake beginning and snake end, if that is same, it's just that it converges to one point. Okay, so that turns out to be effectively nothing. We can continue playing from that spot. Okay, so that is not a problem. Ladder beginning and ladder end is same, so it does nothing. We don't climb up, we don't climb down, we just stay in the same spot. Ladder end is equal to snake end, so now this does nothing. So both are like, nothing harmful over here. Even this doesn't make a, so if ladder end is equal to so you're on the top of the ladder and you're at the tail of the snake, so this does nothing. We can just carry on playing. So this is not an ambiguity. All three other options are not an ambiguity except the third option. Okay. So there's a problem with this question also. They had given a wrong code and then wrong answers to this. So the code tells something about snakes and ladders, but the options are some printing patterns. So we'll ignore this question. We'll carry on with 10th question. Okay, so in this question we are defining a function func, so that is being called. So we are initializing two variables c and I to 10 and 3 respectively. So these will act as running indices. Okay, so when I is below a certain value 6, we are having another while loop inside. Okay, so when this when this iterators, when they lie in a certain value, okay, that if the iterator j satisfies this condition, it will print star, else it will print nothing. Okay, and the iterator is getting updated, j is getting updated. Okay. So this I it just specifies the bounds. It specifies the bounds of j. Okay, so because only if j lies in this greater than or equal to interval, it will print a star, else it will leave a blank. Okay, so while j is less than or equal to 20, this if else conditional occurs. Okay, and then j is updated to j plus 1, and we are going to new line. Now I is also incremented to I plus 1. Okay, so now we are initializing I to 6 and then using another while loop which says while I is greater than or equal to 3, again some other sort of printing happens. Printing, yeah. Yeah, so over here also we are doing the same set of comments. We are defining the bounds of j and then printing a star when j is lying in this bound, otherwise it's a space. So okay, 2 of you have answered. So yeah, the right answer is option D. Both of you got it right. So that's because when the iterator, so J is our main iterator here. I is just it is defining the bounds of J. Obviously when it increments, and the bounds of J will get different all the time. So that's why you see the width of this star pattern, it's getting different every time. Okay, so when in this loop I is getting incremented, and in this loop I is getting decremented. Okay, so it's like so when I is decremented, so the bounds of J will be wider and wider, right? Because it's like yeah. So because of this difference, it is like incrementing till a certain point, the width. So the range of J is incrementing till a certain point, and then afterwards it's getting constructed again and again. Okay, so if you take some initial values and then substitute, and you find out what's the range of J for one iteration even, so you will find out for which condition this kind of increment and decrement are happening in the range of J. So once you get this evaluated, you will be able to say which pattern is it clearly following. So in other options, it's like either the band is being the same, or it is increasing from one side, or it is increasing uniformly in both sides. So it's never decreasing. So when you evaluate this condition, you'll find out that the range of J, it increases till a certain point and then decreases afterwards. Okay, so we have some programming assignments for you. So the first programming assignment says that, so we are defining a matrix called lower triangular matrix. So I hope all of you are familiar with this. So a lower triangular matrix is a square matrix where all the elements above the diagonal are 0. Okay. For example, the following is an upper triangular matrix with the number of rows and columns equal to so this is a typo. So this is a lower triangular matrix because the whatever is below the diagonal is non-zero and above it is 0. Okay, so just correct this. Okay, so our objective is to write a program to convert any given square matrix into a lower triangular matrix. Okay, so the input format is such that the first line of the input contains an integer n, which represents the number of rows and the number of columns. So since it's just a square matrix, you can just define one index, it will just square it off. So from the second line, take n lines of input with each line containing n integer elements separated by a space. So basically your input should be in this format. So you're saying dimensionality So that is 3. So you are saying I want a 3 by 3 matrix, and then you are entering these elements separated by a space in between them. So this is how your input matrix should look like. And once you are giving this input matrix, your output format should be such that whatever elements above the diagonal, it should be 0. So you are converting your square matrix into lower triangular matrix. So the logic in this code is so you have 2 iterators for column and rows. So you will have to differentiate these elements that are in the triangle based on their running indexes. And then initialize those elements, like convert those elements to 0. Okay, update their values to 0, whatever in this position. So it should be for a generalized matrix. You cannot just write for a 3 by 3 matrix, update this position to 0. You cannot do that. Okay, for example, there's a 7 by 7 matrix. Over there also we should get a lower triangular matrix like this. So take your time, please come up with your own piece of code and share it in the chat box. you're stuck somewhere, so the clue is that let's say your I is the column number and J is your row number. So by now all of you will be familiar with how to receive an input integer and then create a 3 by 3 matrix. So all you need to do is, for the positions which are satisfying this condition, J for whenever J is less than I, you need to update it to 0. Okay, so I'll probably share the solutions with you. Okay, so I'm receiving an integer, okay, that defines the size of the square matrix. Okay, so these 3 lines, all it is doing is creating a 3 by 3 matrix. Okay, so the last in range function, as you know, the last index is omitted, so only 1 to A will be considered. Okay, so we are creating a list which is doing the function that I'm doing a function mapping. So whatever is in this input will be typecasted into integer. Okay, and then I'm appending that list L for to my super list M. So that is effectively creating a matrix. Okay, so once I create the matrix, so all I'm doing is I'm defining 2 nested for loops which are running so the indices are running in the range A. Okay, so we can consider this as our so ing can be again column number and then row number. So whenever the column number is greater than or equal to the row number, this set of we are just printing the elements in that area. otherwise we are printing zeros. So wherever we encounter these elements, we are printing 0. Okay, so that's what these lines of code do. Okay, so you can ignore these parts, it's not needed. Okay, so this if else, all it does is this classification, whether j is greater than or equal to I. Okay, so you can also try assignment number 3. So we are given a square matrix of n rows and n columns. Find out whether it is symmetric or not. Okay, so the input format is such that the first line should contain an integer n, which represents the number of rows and number of columns. Okay, and from the second line, take n lines input with each line containing n integers elements, with each element separated by a space. So print output should be such that it should print yes if the matrix is symmetric, otherwise no. An example is given. We are creating a 2 by 2 matrix. We are giving 2 as the dimension. Okay, we are creating a 2 by 2 matrix. So if we take the transpose of this, it is same as the original matrix, so the output is yes. So your code should do initialization of your original matrix and then call a function which will check that your matrix is symmetrical or not. So I hope you all know what is the condition for to check whether your matrix is symmetric. If your matrix is symmetric, it should satisfy this condition that at any position ij, the value should be same as ji. Okay, so if this condition is satisfied, you can call your matrix a symmetric matrix. So this is all you need to test. You will initialize a matrix and then you will do this check. If your matrix satisfies this, you will call it a symmetric matrix. You will print yes, otherwise print no. So please try to do this and let me know if you have any difficulty. So I guess I'll show you the answers. So like last time, we are defining the dimensionality of the matrix, and then these lines, all they do is we input the values of the matrix just like in the last problem. Okay, so there's an empty list, and then there is an iterator, so it's like merging lists onto a list. Okay, so it's like a collection of 3 element lists combined to form a super list M. Okay, so that will be effectively a matrix. So there is a conditionality. If we are calling a function, is it symmetric? Is symmetric function is defined here. I'll come back to that. So if we call this function and we get true as the return value, we'll print yes, or else we'll print no. Okay, so this function is symmetric. What it does is, it's defined over here on top. The definition is here. So for I in range n and j in range n, basically for all elements, we are checking whether the matrix element ij is it not equal to ji. Okay, if this is satisfied, we will return false. Okay, only if this is satisfied, we will return false, otherwise we will return true. Okay. Default it will return true if the diagonal elements, they are and I mean the transpose matrix elements and the original matrix elements, if they are not equal to each other, all of the elements will return false, otherwise we will return true. Okay, so that is the check for symmetry matrix. Once that is done, we'll return yes if the function returns true. Okay, so with that done, this is the last problem for today. So this problem, what it says is that we are given a matrix with n rows and m columns. The task is to check if the matrix is a binary matrix or not. So a binary matrix is a matrix in which all the elements are either 0 or 1. So the input format is such that you will give 2 integers n and m, which will represent the number of rows and columns respectively, separated by a space. So from the second line on, take n lines input with each integer containing m integer elements, separated by a space. Okay, so we'll check if the given matrix is binary matrix or not. If it's a binary matrix, we should print yes, otherwise print no. So an example is given. We are defining the dimensions of the matrix. So here it's not a square matrix necessarily. So we'll define the I mean how many number of rows are there, how many number of columns are there. We'll define both of them. Okay, so then we'll input a matrix. So this matrix, it contains only zeros and ones, so it will give output as yes. So as we are closing in, I'll show you the solutions directly. Okay. So yes, so this line defines how many rows and columns are there. Okay, m and n will be defined here. They are separated by a space. Okay. So this map function is good for typecasting. Whatever input you are giving, it will be typecasted into this function, which is on the left of this command. Okay, so whatever inputs you are giving, it will be converted into integer. So an empty list M is there. Okay, so this is a super list into which 3 different lists will be appended. Okay, so this is just creation of this matrix M. So once the matrix is created, we'll do the binary check whether this matrix is binary or not. So that is accordingly, if it's binary, it will print yes, otherwise it will print no. So the function to check whether the matrix is binary or not is binary matrix. Okay, so the definition of is binary matrix is given here. So over here, there are 2 for loops which will read through all the elements of the matrix. Okay. So for every element in the matrix ij, if it is 0 or if it is 1, it should return false. Okay, so if this conditionality, so what this is doing is, if this conditionality is false, okay, it will return false. So what it is saying is that if all the matrix elements ij, if either they are 0 or they are 1, if this statement is false, we should return false. So that means it's not a binary matrix. Otherwise default is true, returns true. Okay, so we are evaluating this statement. Okay, so this statement will either give true or false. So if that evaluation turns out to be false, effectively it should return false, otherwise it returns true. Okay, so when it returns true, we can confirm that our given matrix is a binary matrix. Okay, so yeah, that's all we had for today. So these resources will be available in Google Drive, the PPTs, and the lectures will be online in YouTube, so you can access through that anytime. Okay, so thank you guys. I'll see you on next Monday. Thank you. Stop streaming.